Welcome to TensorLens. We're about to unpack the wild story of a piece of tech that started out just for video games, but as you'll see, it's now completely rewriting our future. Of course, I'm talking about the GPU.
All right, just look at this. How on earth did we get from this to this? I mean, in a single generation. The answer, it turns out, is the absolutely incredible journey of a piece of hardware designed to let us play Doom that accidentally ended up changing everything. This is the story of the GPU.
So let's rewind to the 90s. Back then, graphics cards were total specialists. They had exactly one job: make games look cool. And they did it using a super rigid, pre-programmed method, a little something called the fixed function pipeline.
And what's wild about this pipeline is that it was basically a black box. If you were a game developer, you could, flip a switch for fog or some basic lighting, but that's it. You couldn't actually write your own code to tell the hardware what to do. It was fast, for sure, but totally and completely inflexible. Okay, so the first big crack in that black box appeared in 2001 with programmable shaders. Developers could finally write tiny little programs of their own. But the real earthquake? That hit in 2006. NVIDIA's Tesla architecture was a game changer. It just threw out all those single job processors and replaced them with one giant flexible pool of cores. And then, a year later, boom, they launched CUDA. This was the software that unlocked it all. Suddenly, the GPU wasn't just for graphics anymore. It had become this accidental generalist, a parallel supercomputer hiding in plain sight. So here's the thing, all this incredible new power needed a purpose, right? The hardware was sitting there, ready to go, just waiting for the right problem to solve. Well, in 2012, it found its killer app. At the ImageNet competition, a neural network called AlexNet, trained on GPUs, didn't just win, it absolutely demolished the competition. And that was it. That was the moment deep learning and the GPU officially became a team. But AlexNet was really just the spark. To get the raging inferno of modern AI that we see today, the GPU needed a new kind of weapon. And in 2017, with their Volta architecture, NVIDIA unveiled a piece of specialized silicon that would literally define the next era of computing. And this is it, the Tensor Core. It was engineered to do one very specific thing with absolutely blinding speed: matrix math. And matrix math is the fundamental language of neural networks. It's how they learn. So you can think of it like a hyper-specialized calculator built just for AI. It focuses all that computational power like a lens. And, well, that's where we got the name for this channel. And these charts just perfectly show the result of that focus. It's insane. In only 8 years, from their Pascal to the new Blackwell architecture, AI compute power shot up 1,000 times. But get this, look at the chart on the right. The energy needed for just one AI token, it dropped by 45,000 times. So it's not just about being faster, it's about being astronomically more efficient. But here's the real secret sauce to NVIDIA's dominance. And it's not just about having the beefiest chip. The real power, the thing that creates this incredible lock-in, is the software. This is how NVIDIA built its unbreakable moat. For nearly 2 decades, NVIDIA has been pouring resources into CUDA, its massive software platform that makes programming their GPUs relatively easy. This created a powerful network effect that's really hard to break. I mean, competitors like AMD with their open source ROCm and Intel with one API, they're trying to catch up, but they are playing a very, very long game of catch up. The software moat is so deep that challengers know they can't just build a faster chip, they have to try to change the rules of the game entirely. And that pressure is leading to some pretty radical ideas. Instead of just copying NVIDIA, people are betting on completely different designs. On one hand, you've got Cerebras, and their philosophy is go big. They're building a single, massive chip the size of a dinger plate to get rid of communication bottlenecks. And then on the total opposite end of the spectrum, you have companies like Graphcore going super granular with thousands of tiny, independent cores for totally new kinds of problems. And then there's what I like to call the open rebellion. Companies like Tenstorrent are trying to build an entirely new ecosystem around open standards like RISC-V. You can think of RISC-V as an open source blueprint for making chips that anyone can use and tweak. Their goal isn't really to beat NVIDIA in a head-to-head race, but to create a flexible, customizable alternative that completely sidesteps that walled garden. Okay, so let's zoom out. The GPU has completely and utterly conquered the digital world. It's mastered our language, our images, our code. So what's next?
The next great frontier has to be the physical world. And this is NVIDIA's vision for how we get there. It's called Project GR00 Groot, and it's for humanoid robots. It uses this fascinating two-brain approach. You've got a big planner model in the cloud doing the high-level thinking, figure out how to get to the kitchen. And then you have a super-fast, reflexive doer model running on the robot itself, handling the insane physics of just staying balanced and moving in real time. And this is the hardware designed to be that doer brain, the Jetson Thor. It's this compact little supercomputer that crams 800 trillion operations per second of AI power, using the same Blackwell architecture as their giant data center chips onto a single board that can fit right inside a robot. So when you really think about it, the journey is just incredible. The GPU started by drawing imaginary worlds for us to play in. Then it learned to understand and create within our own digital world of language and images. And now it's being given a body to actually move and act in our physical world. This leap from digital to physical intelligence is the next grand challenge, and the GPU is, once again, right at the heart of it. The question is no longer if this is going to happen, but just how fast.